all the searching we'd done to date. Oh, we're going to look for fish in the ocean. And what we did was take 1 8-ounce glass and dip it in the ocean and take a look and say, oh, are there fish in there? At least at some point in time, they are or were. This is one of the most interesting questions that humans can ask. And if you were to succeed, that there's a long, path ahead for us potentially. We don't necessarily have to destroy ourselves.
This is StarTalk. Neil deGrasse Tyson, your personal astrophysicist. I got with me my co-host, Matt Kirshen. Matt, how you doing, man?
I'm very good, thanks, Neil. How are you doing?
Yeah, we caught up with you. You're in port in Bermuda. Why didn't you invite us for that?
I am. I'm in a very small cabin on a cruise right now. So I'm on tour right now. I'm doing some lovely theatre shows with Sarah Millican, who's a fantastic UK comic, and I'm doing some headline spots off the back of that. And then in between those, I'm on a boat. So
on a boat. That's why not? What we talk about today, it's a cosmic queries. We're catching up with the search for alien intelligence. Ooh. We should do at least 2 of these a year because that's what the public's appetite surely wants. Right. And there's so much misinformation or speculative information, and I think our audience expects us to at least anchor what's going on. And that's definitely what we intend to do today. We're reaching into the depths of the search for alien life and finding an old colleague of mine from way back, one of the founders of the SETI Institute, Search for Extraterrestrial Intelligence, and that would be none other than Jill Tarter. Jill, welcome back to StarTalk.
Well, hi, Neil. It's great to talk with you again.
Not many people know that you cut your teeth studying stars, correct? You're a co-discoverer of just remind us of that.
My thesis was about what I call brown dwarfs, stars that are too low mass to stably fuse hydrogen at their cores.
Don't we just call those planets?
No, these are a little different. They're a bit more massive than Jupiter. And I was trying to figure out, because I wanted to go looking for them. We thought at that time that a problem that we had that we called the missing mass, where the mass of the galaxy that we inferred from dynamical motions of the stars differed from the mass that we calculated when we added up all the individual masses of clouds of gas and stars. And so there was this missing mass. And I thought that stars that were too small to fuse hydrogen and burn normally might be what could explain that missing mass. And so
could be hidden in those objects. Yeah.
Yes. And the thing was, I tried to put an atmosphere on my model of the star so that I could tell what the temperature or the color of that star would be to help observers go looking for them. And I couldn't do it. It was, so I couldn't get a color, and I called them brown dwarfs. To Edmund Land, brown is not a color. So they're brown dwarfs, and it took us 25 years to find the first one. But now we know they're very plentiful.
So who would have thought that there was an entire category of object living there between the highest mass planets and the lowest mass stars? It's easy to just discounted that as it's a fuzzy boundary. Remind us what got you interested in aliens.
It was a very fortunate accident. When I was doing my thesis, I learned how to program the first computer that we ever had on our desktop. Now, it took 2 people to get the computer up on the desktop, but once it was there, it was ours, right? And so you had to, there was no language, nothing like Fortran or anything like that. You had to program each step in octal, right? So you had to set all the ones and zeros by hand. And I learned that skill. I thought it was great fun. It was a puzzle. And so when I was asked to join Stuart Boyer in X-ray astronomy and his group at Berkeley, who were interested in looking for signs of someone else's technology, I was asked because I knew how to program this computer, and that was the only tool we had to use. And so I did it. And it was, again, a fortunate accident.
Well, as any good collaboration unfolds, every person in that collaboration brings their unique abilities, right?
It's right. And they wanted me because I could program this computer. And so I often tell young people to get some skill, to find something they like to do, and then get better at it than anybody else. So then they have a tool set that they can go shopping to look for programs and problems that they're interested in solving.
And people will beat a path to your door for that
Yes,
expertise.
that's right.
Yeah.
And to be clear, you don't still program in ones and zeros. You go to languages now? Have you got...
No, now there are all kinds of languages that you can use and much better computers.
Obviously, biologists would be intrigued by any kind of life at all
Yes.
discovered on anywhere, microbial even. But your sights are set to even higher goals than that. If I can rank them in this way, maybe that's kind of a bias, I guess, a brain bias. But you're not just looking for any life; you're looking for intelligent life. And what's odd is you get this sense that people think that somehow we don't want to know if there's intelligent life, or that it's being suppressed, or that it's like nothing could be farthest from the truth. And given the efforts that we as a community have put in, especially focused at the SETI Institute, I'm just surprised by this overall sense that somehow people think there's some kind of cover up. Have you had to I presume you've had to contend with this?
Well, at one point, I had to talk to a military panel and promise that our SETI algorithms and antennas would not be able to detect frequency hopping spread spectrum signals, because I believed it. And then it turned out when we got on the air, yeah, we could see those too.
Are they saying they restricted your bandwidth access because they were doing their own searching?
No, they were curious about what I might see, what we, with our equipment and software, might see that they weren't advertising that they were doing.
So you were searching not just for extraterrestrial intelligence, but accidentally but for military intelligence.
Yeah, right. But, I said, no, we can't see that. Not the way we've written our software. And it turned out, our software was better than I thought.
And so how do you go about thinking this up? That surely takes a bit of hubris chutzpah to just declare that if there's intelligence out there, we would be able to communicate with it. We can't communicate meaningfully with other animals here on Earth with whom we have DNA in common. Even a chimpanzee. You're not hanging out with a chimp, say, let's go have a beer later. Oh, sure, Jill, I'm good with that. No. Where do you get your confidence that this even would work at all?
What we can do with our equipment and our software limits what we could possibly find. And so we're looking for someone that can modify its environment in ways that we could sense over the vast distances between the stars. And it's a limited subset of what possibilities there are, because we have the equipment of the 21st century, which is better than the equipment of the 20th century, but not necessarily all powerful. So we can look for certain kinds of what we call technosignatures that would indicate somebody is doing something that nature can't do.
You can't search for intelligent life that does not have technology. So if you found an Earth that had a Roman Empire, their version of a Roman Empire, certainly that's advanced. Certainly they're intelligent, but they don't have radio telescopes. So you would pass them by saying, nothing here, keep walking.
Yes, with the technology that we have today. But, ChatGPT and all the other large language models are going to be able to do some incredible things in the future. And in particular, I think the interesting thing is that whereas any particular search technique looks at certain phenomena at certain frequencies in a certain amount of time, the chatbots will be able to combine or look at simultaneously data sets collected for completely different reasons across the spectrum and across technologies, and might be able to find some correlations that we were totally unaware of.
You're developing a dependence on AI to take you to that next step that you wouldn't otherwise be able to
That's right.
accomplish. Remind me why radio waves is the bandwidth of choice, because that was clearly displayed in Carl Sagan's novel Contact, later becoming the hit film with the character Ellie Arroway. She was a radio astronomer, basically, who is looking for radio signatures out there in space. And the rumor has it that Carl Sagan knocked on your door a few times to try to get some insights into this character. Can you confirm or deny those rumors?
Carl was a member of our board of directors. He wrote a book about a woman who does what I do.
There it is.
Perfectly put. Perfectly put.
That character is Carl. What comes across as Ellie Arroway is actually Carl and his musings and his thinkings and his it's probably too long to go into, but basically Carl would have loved to be able to have one more conversation with his deceased father. And that drove a lot of the thinking.
Nope, that's lame. Ready? Do you harbor questions about the universe? Some long-held bit of cosmic curiosity lingering within you? Or questions about anything at all? You can become a Patreon supporter of StarTalk. You have access to our exclusive question line on our website. Those are where we draw our questions for our cosmic queries.
Some of the most extreme objects in the universe.
StarTalk is a work in progress where we, every month, come up with some new way, some new idea, some new understanding of how to bring the universe down to Earth. We could not do that without your support. Thank you. And as always, keep looking up. Why radio waves and not visible light or any other band of the spectrum?
The fact is that space is not empty, but there are clouds of gas and dust out there between the stars, and infrared or optical wavelengths are absorbed by these clouds, and they can't travel very far through the galaxy. We've never seen the center of the Milky Way galaxy at optical wavelengths because it's just too dusty. But radio, the wavelengths of radio waves are not anywhere near the size of the dust particles in these clouds. And so they basically don't see the particles, they don't see the dust, and are not absorbed by it. So we've been looking at the center of the galaxy at radio waves from very early times in this scientific discipline.
Any aliens would have to know enough astrophysics to conclude that radio waves would penetrate space in the way other bandwidths wouldn't. So we're assuming they'd be on exactly the same track we are in our learning and understanding of the galaxy.
At least at some point in time, they are or were, right? Because they could, in fact, create technologies that outlast their civilization. There are a couple of spacecraft in orbit around this planet that will be there 10 million years in the future, because their orbits will not decay. You know, it's a really interesting question about whether what we're looking for and what is being transmitted overlap in time in this 10 billion year history of our galaxy.
That's part of the parameter space that you speak of so dauntingly, right? Because you can search in frequency, even within the radio wave bandwidth. You could be sending a signal or listening, trying to observe a signal in one band of radio waves, but then there's another bandwidth within the radio waves that could be where the action is, and you would miss it. And maybe they sent a signal that got here 100 years ago instead of today, because there's light travel time for wherever it is. What's this analogy you gave to the ocean? It was the best thing I ever heard. What was it about how much we have searched thus far for aliens? Because you hear people say, well, we've looked for aliens and we haven't seen any, so there probably aren't any. And what's your reply to them?
My reply is that we've hardly begun to look. At one point when SETI turned 50 years old as a discipline, I did a calculation that indicated that all the searching we'd done to date was as if we said, oh, we're going to look for fish in the ocean. And what we did was take 1 8-ounce glass and dip it in the ocean and take a look and say, oh, are there fish in there? Well, there are fish small enough to have fit in that glass, but if you didn't see any, you'd hardly make the conclusion that there were no fish in the ocean. You'd just simply say, you have to look harder. That's where we are. We can do so much, but we can't do everything. And we are always looking for new ways.
If you had told me that calculation when I was just coming on and I wanted to be like a SETI researcher, I would have given up in that moment. I would have said, okay, I'm taking up another job.
Well, you might have, but on the other hand, if you're stubborn, you might have turned that around and said, wow, this is one of the most interesting questions that humans can ask about themselves and their place in the cosmos. And if you were to succeed, you would by inference know that it's possible to outlive your technological infancy and to have a long future. Because if the future isn't long for technologies in general, there aren't ever going to be any two that overlap in time. But if you find something, you know that there's a long, path ahead for us potentially. We don't necessarily have to destroy ourselves.
So that's a profound inference from such a simple bit of information you would glean. Let me see if I can restate it to make sure I understand it. You're saying if technologically proficient civilizations lasted only 1 or 2 centuries, and then they rendered themselves extinct, or something bad happens, or it took them that long to even get to that point, and then it doesn't last long, then when you come upon a planet at a random time in its own evolution, because it could have just been born 1 million years ago, or 1 billion, or 10 billion, you don't know if you're hitting it at exactly that time. And so if everybody only were short-lived, nobody would be talking to anybody, and it would give us very little hope for the future of our fingerprint in this world. Is that a fair characterization of what you just said?
That's correct. But if you don't go looking for it in as many ways as you possibly can, you'll never find it.
You're an astrophysicist posing these questions, presuming that they have astrophysical tools. And I'm wondering if comedians were doing this search, would they presume that the other civilization would have comedians? Is this a natural extension of our own bias?
I mean, I don't know about that, but I definitely know that I've played some gigs where I've wondered whether there's any life out there.
Intelligent life. That's
intelligent life, definitely. Is there anything there?
Let's head out to our cosmic queries about now. You've collected them, Matt?
Yeah, absolutely. As always, Betty from Maine has asked, if you find life outside of Earth, what are you going to do with it?
Yeah, Jill, are you going to conquer it and enslave it and colonize it? What are you going to do?
I'm going to tell the world about what we found and at least my interpretation of what that means. But the world is going to decide how they're going to react. It's not going to be me that makes that kind of decision.
And what confidence do you have that response would be what you would consider appropriate?
I don't know, Neil.
That's not very helpful. Come on, Jill.
Oh, come on. Given the politics of our country, I don't know. But all I can say is that you'll know what I know.
So Atticus from Soddy Daisy, Tennessee, who is 10 years old, says, the quote from Arthur C. Clarke, 2 possibilities exist. We are either alone in the universe or we are not. Both are equally terrifying. This keeps me up at night in an amazing, not scary way. Please give your thoughts on the idea behind the quote.
Oh, Atticus.
Are 10-year-olds allowed to have these kind of profound thoughts?
I know. Also go to
you be
bed,
in the
Atticus.
playground or something?
Or at least not having to stay up at night worrying about it.
Well, Atticus, we all share that profundity of thought that delays your slumber. And Jill, let's hear from an expert here. Jill, are both terrifying to you?
Both are extremely significant. One is not so hopeful in terms of the continued existence of life on Earth. The other is something that would be incredibly exciting and impactful to know. Because if you know that somebody else has made it through this very precarious technological phase that we're in, then, there's an answer. There's some way to do it. And that inspires me, anyway, to go looking harder for that answer.
Here on Earth?
Yeah. Somebody else made it through. We can too.
Okay. I like that.
Well, while we're talking about the actual process, it's a pretty top-level question. Vincent Thomas says, what exactly do you listen for out there in the stars?
And just to be clear, I just want to the radio telescopes are like other telescopes. They're detecting light. So somewhere in the decades past, people have equated a radio telescope with listening to sounds, and people think we're listening for sounds. And they did that with, in the movie Contact, where Ellie Arway is listening to her data. But these are observations of radio light, correct? And we're just being loose when we say we're listening. That's like saying, let me listen to the sun and just look at it, okay? No, you're receiving light.
Martin LeBlanc from Montreal does end the question with, and Neil, for this episode, I dare you to change your saying with keep listening up.
Oh, okay, maybe I'll do it just for him. Okay.
Okay.
But Jill, let's get your reaction to that.
What we use instruments to try and detect is the kind of emissions that nature can't do. And that generally means some kind of transmission that is very compressed in frequency, because nature doesn't do that. Nature's emissions come from gazillions of molecules and atoms, each of which is vibrating or rotating and emitting a very specific frequency. But all of the atoms and molecules are moving with respect to one another so that the ensemble signal is Doppler broadened. So each of these individual transmissions from a molecule or an atom gets added with all the other molecules and atoms that are all moving relative to one another, and you get a broad signal. But technology can get around that. We have means with lasers and masers of compressing a signal into a single frequency or a small range of frequencies, what we call narrow band transmissions. And either we'll learn something unexpected about nature and find that nature can do this job and trick as well as we can or better, or we'll find evidence of the technologies that we're looking for.
And so it's not just that the signal exists. You might want or expect or hope that signal to also contain information within it. Again, in the film Contact, the signal was, at least in the film version, it was prime numbers, I think it was, right? Mm-hmm. And whereas I think in the novel it was digits of pi, perhaps, but I might be confusing my memory. But within the signal, there was information. So can you decode, if you did find the narrow band, or do you have a next layer analysis to see what they might be trying to tell us?
Well, again, that's one of the reasons that I want to tell everyone what we may have detected and what we've interpreted, because there are far better code breakers out there than me. And so we'd be eager to engage the intelligence of the rest of the world to help us understand any information. And one thing that I should mention is, although we talk about listing and we talk about radio, and I've argued that other frequencies don't travel as far through the galaxy as the radio wavelengths, we are also trying to take the techniques that we have and push them into the infrared and the optical for sources that are closer by.
All right. Well, it sounds like you're on top of that situation.
Well, who knows? I'll let you know when we succeed. We'll know we've done the right thing when we succeed.
So Jonas Dravland says, "Good day, doctors and lords. Jonas from the Appalachian foothills of North Carolina. If there were a SETI-like organization on a distant star system, how close would they need to be to detect us? Would they be able to watch I Love Lucy? And should they expect to pick up their domestic radio activity, or are we basing our search on the presumption that they are sending signals intended to advertise their existence?"
Ooh, yeah. So I'd love that, because our earliest radio signals are just our earliest escaped television broadcasts, right? Now going into 100 year, 80, how many years ago? I Love Lucy was 1950s and 60s. Well, the Honeymooners. Are they going to learn how men and women interact on Earth from those two shows?
From 1950s TV and earlier radio?
I think what might be detected is not the information content of the television program, but the existence of the carrier signal that transmitted that information. Or maybe once we detect evidence of someone else's technology, they're going to explain, and we translate it somehow, they're going to explain to us why Lucy and Ethel shouldn't have had subservient roles.
or Alice and the Honeymooners. Yeah, all of the above.
Right.
Catch us up just briefly, take a break from the questions and ask you, what telescopes do SETI are in the arsenal of SETI's control?
Well, we have a special telescope that we've developed for working in the infrared and optical that we call optical SETI, or laser SETI, I should say. These are special instruments that we've developed. Otherwise, what we use is existing telescopes that are part of the astrophysical realm, and we can essentially piggyback on the signals being detected by those telescopes, which are looking for other things in other ways. But we can carve out a piece of that signal without affecting the primary observer, and we can analyze it looking for these technosignatures. So it's really anything out there that's looking at the universe. We are eager to replicate their data so that we can analyze it in a different way.
And the SETI Institute is mostly privately funded. Is that correct?
Yes. Yes. We do, well, I shouldn't say that. SETI at the SETI Institute is privately funded, but we have over 100 PhDs at the SETI Institute who are looking in many different ways to discover life beyond Earth. And these programs are typically funded by the National Science Foundation and NASA. So we do have government funding, and we're very nervous right now about what's going to happen.
Science funding in many realms today feels like, science is just optional. Other things are more important. There's been a shift in priorities, which will have consequences that people we foresee, but the general public doesn't really, given how much of modern civilization pivots on the moving frontier of science. But okay, let's keep going. Matt, what else you got?
Yuikia from India, living in California, says, how detectable is Earth as a life-harboring planet from a nearby star system? Should we put any large visual structures around Earth or Jupiter so that intelligent aliens can detect them as non-naturally occurring structures when they monitor the transits around the sun? Thank you to SETI and StarTalk for trying to answer the most fundamental questions and promoting scientific thinking.
Oh, cool. Yeah, are we doing all we can to get noticed?
No, we're not, because there are other priorities for funding to do the kinds of things that are being suggested in this question. Is not cheap. To build structures, to modify orbits of asteroids or planetesimals, that's all really difficult and expensive. And while it might happen for other reasons, such as mining rare earth elements, which we are depleting on this planet, it's not likely anytime soon to be done specifically for attracting the attention of any technologies out there. It's just unfortunately not a high enough priority.
Jill, I remember a zillion years ago, I asked you a question after a colloquium you gave, and you gave the cleanest, simplest answer to a question similar to this one, which was, I asked, why are we spending so much time just, quote, listening for aliens? Why don't we just blast the universe with our own signals? And at the time, what you said was, it costs almost nothing to just passively listen for signals. So you can get away with that without breaking the piggy bank. If you want to actively send signals out, that's orders of magnitude, way more money than what it would cost to just listen. And because I thought it was unfair that if everyone were doing what we're doing, then the whole universe would be listening for other aliens and no one would be transmitting, and everyone would conclude there's no other intelligent life in the galaxy.
That's right. If everybody's listening and nobody's talking, we're not going to succeed. But another impediment, if you wish, to this idea of deliberately transmitting to make ourselves known to the cosmos is the fact that if we do that, that's going to interfere with an enormous number of other disciplines and searches and technologies. I mean, it probably would mess up your GPS just enormously,
Oh,
right?
okay.
Right.
Yes, cost is the major impediment, but there are unintended consequences of doing powerful transmissions.
Well, while we're talking about ethical considerations, Hugo Dart from Rio de Janeiro, with Hugo's 7-year-old daughter Olivia, who's also a big fan of StarTalk, ask, what parallel, if any, exists between how we treat animals and vegetable species on Earth and ethical parameters we can establish for dealing with alien life? And I'm just going to add to that, how do we know in this equation that they're the vegetable/animals and not that we are the vegetable to them?
Exactly. Exactly. Yeah. So Jill, is there sort of an ethical standards that you guys like a manifesto that plastered up on your walls at the SETI Institute?
Yes, a long time ago, back in the 80s, we worked with the International Institute of Space Law to create a declaration of principles for
Nice.
dealing with the detection of extraterrestrial technologies. And one of the important bullets in that protocol is make sure you get it right. Make sure that whatever you're going to announce is not some flaw in your detection system, that it really is what you're saying it is. And that's that's so important that now we actually suggest that the most valid way of searching is to search with at least two instruments widely separated on the surface of the Earth, so that the signals received by those two instruments will have a calculable Doppler shift between signals arriving here and signals arriving there. And that is a good signature to be looking for, in addition to whatever's embedded in the information content of the signal.
Right, but that's not related to the ethics of how you would treat aliens, right? So in the code of ethics, that's good to make sure that you measure that what you say is what it is. But if we come upon aliens, is there some code of how we would treat them?
You're talking about ethics, and I was talking about a declaration of principles. The ethics are going to come from probably the religious entities across the planet. And those are different, and they have different perspectives. On some would be threatened by this discovery because it isn't consistent with their teachings, and others would simply say, no, no. Many different life forms in the universe are just another example of God's, or let's say God, omnipotence and power. So the ethics come not from the technologies, not from the principles that I can have anything to do with, but they're going to come from religious entities. And as long as you're talking about microbes, nobody much cares. But once you start to talk about intelligent beings, then these other codes of ethics get brought to bear. And again, as I said, they're not all going to have the same conclusions or the same desires.
That would make it very difficult given how many religions there are in the world and they'd all have to agree on what a code of ethics would be. And if they're all coming from different religious traditions, that could be very hard to arrive at an agreement. and we have our first encounter. And so we have to see how that unfolds for sure.
Yeah, and there's another unintended consequence that you might not think about, and that's geographical. So suppose that whatever technosignatures are detected or detectable are only detected from extremely southern locations or northern locations. Now, if it comes from the south, from the Antarctic, we already have some methods or agreements for how to share data that's collected in the Antarctic. But if you get to a point where it can only be seen from the Arctic, now you're in really hot water because so many different countries or nation states are claiming sovereignty over different pieces of the Arctic.
The Chinese have the biggest radio telescope in the world today. So it could be that the first alien contact will be with Chinese astrophysicists.
That's correct. And they built an amusement park right next to that telescope. Yes, I worry about the potential for creating a haves and have-nots.
We got some more. So Dave McNeely from San Diego, California, says, Dr. Tarter, it's a huge pleasure. I met you once at the inaugural SETICon in 2010 in Santa Clara. I'm studying for a master's degree in space studies, and SETI is an enormous driving force in my life. My question, I'm sure you get this all the time, but considering radio technology is limited to the speed of light, doesn't it make sense that more advanced extraterrestrial intelligences would be communicating with each other using something different? Surely they are not using radio communication internally across vast interstellar distances.
Yeah, how much of the physics that we know today is limiting us on the possibility that there's new physics in the future? Yeah, I mean, we have the bias of our own times, all right? And we're thinking they would use radio waves moving at the speed of light. And do you guys think about possible future technologies that could be game changing on this landscape?
Yeah, we think about it, but we don't know how to do it, right?
Okay, that's the answer. That's the simple answer. Yeah, I think in Star Trek, their communication channels are on, what do they call it? Subnet. Where's Charles when you need him? Our geek in chief. In Star Trek, it wouldn't be helpful to talk to Starfleet Command using radio waves limited by the speed of light, because there would not be a witty repartee between the captain and headquarters. So there's some subnet or something that apparently there's signals that can get through instantly, just like a regular phone call. And so it's solved in Star Trek, which is several centuries in our future.
Something to look forward to.
Yeah, definitely.
Yeah, right. If the Star Trek folks, the producers and creators can tell us how to do it, then we should listen. But so far, superluminal communication is not within our reach. Superluminal simply means faster than the speed of light. And we
That's
talk
a cool
about
word.
it. People write papers about it, but we don't know how to do it.
And it's a cool word anyway that kind of means what it sounds like it says. So I like words like that. So I think, Matt, we have time for like one more, a good one. You got a good one there?
Okay, well, I think this is a good, a sort of less technical but deep question. Pinky MacGyver asks, how lucky do we have to be for our ability to detect life to coincide in time with that life's ability to be detected?
Does that take us back to your glass of water in the ocean analogy?
That's absolutely correct, Neil. We have to be pretty lucky in order to end up being cotemporal, being able to be around at the same time for both transmitter and receiver. So unless L, the factor in the Drake equation, which says how long technological civilizations or the technology persists, Unless L is large, there's not going to be any success. There won't be any overlap. But again, I'm of the opinion that I like to think about turning that around and saying that if we detect someone else's technology, it means that L has to be large and that we have a long future.
And remind us about the Drake equation, which played a role in the movie's Contact. If someone wants like a full celebration of the Drake equation, but can you just remind us where that came about and what it attempts to do?
Well, the Drake equation is actually the agenda for a scientific meeting that Frank Drake put together at Green Bank, West Virginia, at the telescope there. And it says the number, and it's actually not an equation because it doesn't have a solution, but it's written as the form of an equation. So it says the number of technological civilizations in the Milky Way galaxy with whom we could communicate can be estimated by taking the rate of star formation in the galaxy and multiplying that by the fraction of stars that have the appropriate conditions to be suitable hosts for living planets, multiply that by the average number of such planets around each star, multiply that by the fraction of those planetary planets that develop a technology, multiply that by the average longevity of the technologies, and you end up with an estimate of the number of communicants.
Zero.
It can't be zero because we're here. It doesn't say.
Oh, we're here. Okay, we got to get at least one out of that equation.
It's at least one. But unless L is large, it's a small.
Yeah, very good.
So you're saying we use the length that we've existed as a civilization as our best guess for how long civilizations can run on average.
Yeah,
so
we have no other guess. Correct.
Matt, it's actually a lower limit. We know that it's possible to have a technology exist for at least as long as we have, and that's 100 or so years. But we don't know what the upper limit is.
And that 100 years comes from the earliest radio telescope signals that we could detect.
Yeah, it actually
that put us on the map, on the SETI map.
Right, back to Cacconi.
What are your thoughts on all of the congressional hearings regarding sightings of unidentified anomalous phenomena rebranded from UFOs? Were you tapped for your expertise in any of this? And what are your reflections on it?
Well, first of all, I have no expertise in that, and nobody came knocking on my door. But there's a gentleman by the name of Nick West who has done a lot of careful studies of some of the most touted and the most recent releases of videos from the Navy in particular, and has come up with, all right, if you actually analyze what you're seeing and not looking at it with a bias that what you're seeing is something having to do with an extraterrestrial spacecraft, you can come up with very plausible explanations.
So at least somebody is tasked themselves to just be sort of not jump to extraordinary conclusions. As you quoted Carl Sagan earlier, if you have an extraordinary claim, there should be an extraordinary evidence behind it. And if you can explain the evidence with ordinary means and ordinary physics and ordinary technologies, ordinary detector glitches, then, go home.
Occam's razor, yes.
Well, what we should do is if aliens ever land, we should bring them to you, I think. That's
I don't know. Maybe you should bring them to the cats of the world, or the elephants of the world who have amazing memories
Oh,
and capabilities that we're just beginning to
other
understand.
species. This topic will never go away because it has unlimited public appetite, and as evidenced by every next movie that addresses that phenomenon. In fact, just now there's Alien Earth just came out, that's the Alien franchise, but now the alien's no longer in space; it's on Earth. Okay,
That's
so
the last thing we want.
I know.
Who let that happen?
Who let that? Somebody left the door open. They forgot to close the door behind them.
So
So yeah,
careless.
there's no end of this, and movies are making money hand over fist. They should. So, Jill, they should have a volunteer tax that any percentage of a movie that depicts aliens should be given to SETI. I think I'm going to post that on social media. That's what I'm going to do.
That's great, Neil.
That's-
Start the
I've
campaign.
been making that argument for a long time, and it hasn't taken hold. So maybe if Neil,
Let me see what I can do with it.
we'll get there.
Well, all right, Jill, it's been a delight to have you back on to StarTalk. I like checking in with you on the latest developments in the SETI universe, the SETIverse, and good to hear that it's alive and well and funded, at least at levels that, at least for now, it's funded. And we're also delighted to learn that when you make contact, you will tell the world. You're not going to run to members of Congress and keep it in a locked box in a back room. You'll do what any scientist would do in your situation. And so we look forward to that day.
Me too. I look forward to that.
What was that question, Matt? Unless they think we're carrots, what was it?
Yeah. Well, are we there animals and plants? I don't know.
Right, yeah. Are we there?
Vegetables?
Yeah. Are we the something to be eaten? Because they're long voyage. They're hungry. Tasty humans.
Let's hope they're fussy eaters. They don't like their broccoli.
They have the technology to come here and consider you as lunch. They don't need that. They can manufacture you.
Oh, that's true. But it might be a gourmet thing. We don't need meat, but people still do it. It could be a status thing.
I will die knowing I am tasty. How's that? Is that? All right, we got to call it quits there. So, Jill, it's been a delight to have you back on.
Oh, it's a pleasure, Neil. It's always great to talk to you.
And we'll check in with you again every now and then to make sure we don't fall too far behind on the latest SETI developments. And Matt, we can find you on mattkirshen.com. You're on the road.
Absolutely. I'd love to see StarTalk listeners out in my audiences. So yeah, mattkirshen.com for all my dates, and Probably Science is the podcast.
So this has been another episode of StarTalk Cosmic Queries, the SETI edition. I'm Neil deGrasse Tyson, and as always, I bid you to keep looking up, keep listening up.